welcome to my fourth video in the series about lungs, and today we're going to look at dissociation curves. So before we actually look at a graph to do with the dissociation curve, we look at some of the terms here. So hemoglobin. Hemoglobin is the chemical found within red blood cells that actually carries the oxygen. And so it's the thing that loads the oxygen onto the red blood cell. And myoglobin's the version of hemoglobin found within the muscles, and it does a very similar thing. It loads oxygen onto it. And so what the curve actually shows us is how much the hemoglobin is saturated, and by saturated, how much it is filled up. And so it's represented usually in a percentage, so 100% fully saturated, 0%, obviously it hasn't got any oxygen attached to it at all. Dissociation, this basically means where the oxygen is removed from the hemoglobin, so where it unattaches. So a couple of things here. So the higher the partial pressure of oxygen, the higher percentage of oxygen saturation to hemoglobin. So this is basically saying the more oxygen that you have in the alveoli or in the blood, the more of it's going to attach physically to the hemoglobin. And so this graph shows us what a typical dissociation curve looks like. And so what you have here is the percentage of partial pressure of oxygen, and here you have the percentage saturation of the hemoglobin. And so what this shows is it's got a kind of S shape to it. So here, and what it shows is at lower partial pressure of oxygen, there's less oxygen actually on the hemoglobin, and up near a very high partial pressure, so 100, you'll find that the percentage saturation is also very high as well. Now if you look at the lungs and you looked at the partial pressure of oxygen found in the lungs, would be very high, so it would be approximately this value here, so 100. Now you can see here that at 100 the percentage saturation is very, very close to maximum, and that's what you want. You want, because there's lots of oxygen present, you want lots of the oxygen attaching to the hemoglobin. And as you move kind of down this graph and look to this section here, this tells you that the muscle tissue, the partial pressure of the muscle tissue is roughly 40, and you can see here that the dissociation, or the saturation level here is roughly 70%. So that tells you that 30% of the oxygen that was attached to the hemoglobin is now unattached, and so it's then free to move into the cells, and therefore it can be used for respiration. So ideally what you want is a very high partial pressure in the lungs and a reasonably low partial pressure around where the tissues are. That way, in the lungs, loads of it attaches to the hemoglobin, and then when you get to the tissues, what you want is a lot of the oxygen off the hemoglobin, and therefore it can then move easily and freely into the muscles and into the cells that require it. So here we have listed a few things that can affect the saturation of oxygen to hemoglobin. One of the first ones is temperature, and next one is the partial pressure of oxygen, which you've seen from the previous graph. An increase in CO2 has a big effect on the level of saturation. That's the one we're going to focus on in a minute, and also the increase in acidity, and so that can also be related to the level of CO2. Generally speaking, the higher levels of CO2 you have in the blood, the more acidic it's going to be. And this shift that you get in the dissociation curve is called the Bohr shift, and it looks like this. And so this is your normal kind of dissociation curve, this one on the left here. If you look to this one on the right, this can be as a consequence of a change in temperature, a change in acidity, but specifically the one that we focus on within the syllabus is looking at the level of CO2. What you tend to find is when you produce a lot of CO2, what tends to happen is this curve tends to shift to the right, and we'd refer to that as a Bohr shift. Now, the reason why this happens, and the reason why this is a benefit, is because if you look at the concentration within the lungs, that doesn't really affect the percentage saturation. So if you look at the values here for both lines, then they both have a saturation level of roughly 100%. Now, having the curve shifted to the right, what that means is it will unload oxygen at a higher partial pressure, and what this will enable is it will enable more oxygen to get to the tissues that require it. and this is obviously a benefit, particularly if you're exercising. So higher exercise levels will increase your requirement for oxygen, and therefore you're going to need to get hold of more oxygen. And so in the if we were to compare the two lines here, so if we looked at the actual partial pressure of oxygen found within the muscles, so roughly here, if you look here, 50% of the oxygen has dissociated from the haemoglobin, whereas with our original line it's up near 80%. And so you're getting nearly an extra 30% oxygen with this curve shifted to the right, and hence why it's a benefit.